The session is try to understand what exactly is a polygon, right? Now, as its definition says, a simple closed curve. Remember, the simple curve, something which should not basically cross, all right, itself. And it's a closed curve, all right? It has to be simple and it has to be closed, made up of only line segments. And what exactly line segments? Line segments are those guys which have ends, all right? They have to end. And let's say this is a line basically. Now, in terms of a diagram, if I say that I have something like this, so I can see that if I name these things, let's say this guy is A, B, C, and C. I can't name this guy because this guy is still continuing. This guy is not a segment because it's not finishing here. It can be pulled on this side and this side, but I cannot pull BC. BC is fixed, all right? AB is fixed and AC is fixed. These three are line segments, what I have, right? These three are actually line segments. I can write them like that, all right? But I cannot say that this is a line segment. This is a line basically because it can be extended one end. So understand what exactly is a segment which has two fixed ends. It cannot be pulled anymore, all right? So I can say in this case, AC, BC and AB are line segments, but I cannot say this is a line segment, all right? For all I talk about, let's say this guy. This guy looks like A, B, C, D. This guy I can say is a polygon because, why is that? Because all these four lines are basically line segments, all right? They're not only lines, they're line segments. Nothing can be pulled anymore, right? They're fixed. And it is also a simple closed curve. It's closed because I can start from here, I can finish the same point. And it's simple simply because it is not overlapping or intersecting itself, all right? Now let's talk about like this guy. This guy is not a polygon, this guy is a polygon. So let's draw a couple of diagrams and put them into this criteria, which are polygons and non-polygons. So I can say this curve which we actually drew is not a polygon, though it has got three line segments. These two guys would not be segments, so that makes it not a polygon, all right? Now let's talk about another curve. Let's say this guy. Yes, this guy is a polygon again, right? So it can be this guy. Even this guy is a polygon because, why? It is not intersecting, it is closed, right? Just it says not intersecting, it means it is simple, and I can start from here and finish the same point, right? And all the lines here, or I can say all the line segments, D, E, and F, right? All are line segments here. These are all line segments. Nothing is line, nothing can be pulled anymore. So these three are polygons, I can say. And these guys are non-polygons. It can be like that. Let's say like this. This again, not polygon, right? Or let's say if it is crossing itself. This is not a polygon because it is crossing itself there, right? Though this guy's got all segments, let's say A, B, C, D, and E. There are all segments, definitely, because nothing can be pulled, nothing lines here, nothing erased here, in fact. Now, this guy is not a polygon just because it is not simple, right? It is not simple because it is crossing itself. So we understand what exactly line segments are, and what are simple curves, and what are polygons, which are non-polygons.